Welcome engineers, my name is TravisIQ and today I'm giving you my favorite CCNA question of all time. VLANs, trunking, security, all of it wrapped into one itty bitty thing. Let's go! Why is it common practice to change the default native VLAN? Take a second and think about this for yourself before I answer this question. Maybe pause it right here. Why is it common practice to change the default native VLAN? The reason it's such a good question is it actually encompasses a ton of topics. So you need to know what the default native VLAN is, obviously. You need to know what the native VLAN is, right? You need to know what the default behavior of ports are, what the default VLAN is for ports on your switches. You need to know about trunking. You need to know about tagging. So why do we need to change the default native VLAN from its default to something other than the default? Well, this actually encompasses a lot of things. So what's the native VLAN? The native VLAN is the VLAN that all traffic gets placed in when it is untagged on a trunk link. A trunk link is typically, right, a switch-to-switch link. It's not always the case, but on this switch-to-switch link I have defined here, this is a trunk link. What is a trunk link? A trunk link is a link that allows for multiple VLANs to traverse the same physical link. You need to know the trunking component. You need to know what the native VLAN is on that link, and then you need to know what the default behavior is. So what's the default behavior? Well, the default native VLAN on this link, when you set this link up, is the number 1. It's 1. That's the VLAN ID, VID. Okay, then you're like, Travis, why does that matter? Well, the VLAN ID matters because this is the VLAN that traffic gets placed in that it can then communicate with on other ports on that switch, other devices on that switch. Okay, so the default native VLAN is equal to 1. Okay, well, what's the default behavior of all switch ports? What VLAN are the switch ports in by default? The reason you need to know this is because it's going to be relevant to answer the question, but that doesn't necessarily make you think about it when you first see the question. What is the default behavior of those ports? The default VLAN, the VLAN that all the ports are in by default, is 1 as well. So if the ports are all placed in VLAN 1 and any untagged traffic on this trunk link gets placed in VLAN 1, that's a problem. This is where we need to synthesize the info. You needed to know what the native VLAN was. You needed to know about trunking links. You needed to know about the default behavior of the ports when they're unassigned by the switch or by the administrator on the switch. Now you can see the problem here. If I can get an untagged frame on this trunk link, then I can get that frame into VLAN 1, and VLAN 1 is also the default VLAN of any unassigned ports. If you messed anything up or if you didn't change the default behavior for whatever reason, now I have access, basically as a malicious user, to any of those ports or any of those devices that were placed in VLAN 1 by default. You can see now that this is a security issue. Maybe this is one of my favorite questions because even if you are an experienced network person or maybe a moderately experienced network person, you're like, oh yeah, we always change the default native VLAN whenever we set these switches up and whenever we set these trunk links up. But you never really thought about why. So now you have a question here on a CCNA that asks you, I need you to know all these things and what happens, and then I need you to think about why it happens too and synthesize that information. So does the default native VLAN change improve the speed of the trunk links based upon the information I have given you here? No, it doesn't improve the speed of the trunk link. And you could make an argument, right? A very loose argument. Well, if there's no tagging of traffic and I don't have to recompute the frame checksum, maybe if I use the native VLAN, but it's telling you to change the native VLAN. So even that's not right here. Let's go down. I always like to answer the questions by removing the wrong answers. So routers can participate in VLAN communication. Changing the default native VLAN has no effect on routers being able to conduct basically inter-VLAN routing in this case, or the switch being able to conduct inter-VLAN routing. This is not correct either. They're trying to show you topics that are associated with VLAN segmentation, inter-VLAN routing, but that are not answering this question in any way. And then finally, this allows spanning tree to operate across all of the VLANs. The default native VLAN change has nothing to do with spanning tree. All of the information that I have given you here does not associate with spanning tree in any way. And so now that I've eliminated these 3 answers, we can come back and look at the answer that is correct here, which is to enhance network security. And it was intentionally left vague as well to give you no additional context. You're like, this looks like the most wrong answer of all: improving speeds of trunk links, routers participating in VLANs, spanning tree operating across VLANs. If you didn't know the answer, you would say, oh, these are much more related to the VLAN component of the native VLAN and default native VLAN change. And then they give you this very empty answer: enhance network security. You're like, I guess that could be anything, could be enhancing network security, but no, this explicitly enhances network security. It takes the default behavior of the native VLAN and changes it so that the native VLAN, when you see an untagged frame on a trunk link, gets placed into a VLAN that is no longer associated with the default behavior. And typically, now that you have some more context here, you should know, and this will help you answer this question as well, we changed the default native VLAN. We changed the native VLAN from the default to basically a black hole VLAN, to something like 999, because basically we don't want to be using untagged frames on trunk links. We want to be explicitly tagging the frames for security so we know exactly where they're going. So we don't even want to use the untagged frame component. You're, Travis, why do they even leave the frames untagged for any reason? Why does this even exist? I'll cover that in the VLAN in the VLAN discussion to follow, but that's the answer to this question: to enhance network security. And I love it because it's short. It's several words long, and the answer is short as well. But you need to know all of these additional components to answer that question. That makes this my favorite CCNA question of all time. I hope you found that informative. Take a look for the VLAN discussion that we have to follow this. As is always the case, engineer, break stuff, have fun. We'll see you on the flip side. Let's go.